Hey everyone, and welcome. In the world of software, there's really only one thing you can count on, and that's change. So today, we're going to dive into a design philosophy that's all about building systems that don't just survive change, but actually welcome it. It's called the open-closed principle. So, let's get into it.
But first, let's start with a question that I am willing to bet has kept you up at night. You add one seemingly simple new feature, and bam, 3 other things that were working perfectly fine suddenly break. Why does that happen? Sound familiar? Yeah, we've all been there. Well, a huge part of the answer has to do with this idea of software rot. It's this gradual decay that happens to our code over time. With every little change, a poorly designed system can get just a little bit harder to work with, a little more tangled, until it's a complete mess.
And these are the symptoms, the 4 horsemen of software apocalypse, right? You've got rigidity. That's when one tiny change forces you to chase down edits all across the code base. Then there's fragility, where you fix a bug over here and for some reason, something totally unrelated breaks over there. Immobility is when you have a great piece of code, but it's so tangled up you can't reuse it anywhere else. And my personal favorite, viscosity. That's when doing the right thing is just so painful, it's way easier just to slap on a hack. This is the mess we're trying to fix.
So how do we fight this rot? How do we build software that lasts? Well, we fight back with one of the most powerful ideas in software design, a cornerstone of the solid principles, the open-closed principle, or OCP for short.
So here it is, the classic definition from way back in 1988. Software entities should be open for extension, but closed for modification. Now, when you first hear that, it sounds impossible, right? A total contradiction.
Which leads us to the million-dollar question. I mean, really, how on earth are you supposed to add new behavior to your code without actually changing the original code? It just doesn't seem to make any sense.
The answer is one single, incredibly powerful word: abstraction. This is the whole secret. Abstraction is the key that unlocks this entire principle. It's the secret sauce that lets us build these flexible, rock-solid systems.
Okay, so let's unpack that. Closed for modification, that just means our core logic, the stuff we know works, the stuff we've already tested, we don't touch it, we put a lock on it, because every time we change it, we risk breaking something. But then, open for extension, and this is the magic part, means we can still add new features by writing brand new code that just plugs into our system through a well-defined contract, like an interface.
All right, that's enough theory. Let's make this real. Let's see what this actually looks like in practice, with some code.
Okay, check this out. This is a classic example of what not to do. A shipping cost calculator. See that big if, elif, else chain? Every single time the business dreams up a new way to ship something, overnight, international, by drone, whatever, a developer has to come back to this exact spot and add another elif clause. This code is permanently open for modification, and that's exactly what we want to avoid.
So how do we fix this mess? It's actually pretty straightforward. We use something called the strategy pattern, which is basically OCP in action. First, we create an abstract blueprint, an interface we'll call shipping strategy. Then, for each shipping method, we create a totally separate class that follows that blueprint. And then, the most important part, we change our main calculator so it only knows about the abstract blueprint, not the specific details.
And voila! Look at the after. The new shipping calculator is so simple and stable. It's wonderfully dumb. It has no idea what standard or express shipping even is. All it knows is how to talk to something that behaves like a shipping strategy. So now, when the business wants drone delivery, we just write a new drone shipping class. The calculator itself, we don't touch it, ever. That is being closed for modification but open for extension. Now, a great principle like OCP doesn't go it alone. It's got a whole team of other solid principles working with it, and it really needs them to be effective.
Think of it this way. The single responsibility principle, that's your foundation. You can't create a good abstraction for a class that's trying to do 20 different things. Then you have the Liskov substitution principle. That's your safety net. It makes sure that any new extension you plug in will play by the rules and not crash the whole system. And finally, the dependency inversion principle is the actual mechanism, the plumbing, that tells us to rely on those stable abstractions instead of a bunch of messy details.
You know, getting good at OCP isn't just a coding trick. It's bigger than that. It's about shifting your thinking. It's about starting to think like a software architect, looking at the long-term health and evolution of your system. I absolutely love this quote because it's so true. OCP is a compass, not a GPS. It points you in the right direction, but you still have to navigate. For instance, in something as critical as the Linux kernel, the developers are constantly making trade-offs, sometimes choosing raw performance over pure design. The point isn't to follow a rule blindly, it's to use your judgment to isolate the parts of your system that are most likely to change.
And this, right here, is why this principle is more critical today than ever before. Think about AI. It's like having the smartest, fastest junior engineer on the planet writing code for you. But that engineer still needs direction. It needs a good blueprint. Our job, our real value, is becoming the architect who designs that blueprint, ensuring the system can evolve gracefully for years to come.
So I'll leave you with this question to think about for your own work. The next time you sit down to code, ask yourself, am I building a brittle brick wall designed to resist change at all costs? Or am I building a flexible platform with plug-in points designed to embrace it? That's the whole art of the open-close principle.